CYBERNET radio fans, hello! I'm back here with new modification about the output power on AM and FM. For example, here for the PTBM121 here, this is a Ham International Concorde Q, and the transceiver here has an output of about 6 watts on high power and about 2 watts here on low power here on the power switch, and we will check that. Okay, here on low power about 2.5 watts, and high power 6 watts. That's the maximum here on AM and FM. And with a small mode we can pull up the power output to about 10 to 12 watts in high power and about 5 to 6 watts in low power. Okay, what's the problem here? Okay, this is a schematic diagram of CYBERNET PTBM121 here, drawn by Rick Jackson of Euroradio Co. Ltd. And this is the problem here. BAS. This is a 9 volt point of the regulator here. And this 9 volt goes here to the RV13. This is the voltage regulator or voltage adjustment for the input of the base here of Q36-2ST837. If we have here about 9 volts here, the output of the emitter of Q36 is also about 9 volts. And this 9 volts here goes to the collector of the final stage of the 2SC1969. And if we have an input of about 12 volts here on the base, we have also an output here on the emitter of about 12 volts to the input to the collector of the final stage transistor. And then we get more power. And that's the solution. We cut the track here from BAS, from the 9 volt point to the input leg here of RV13. And then we make a new track here from this point or this point to the input of this RV13. This is the source point from the on-off switch here, directly from the on-off switch. And then we get about 13 volts here on this point and about 7 to 10 volts here on this point. Yes, and here we have the Darlington, the Q36 here, 2SCA37, and this is RV13. This is the AM power adjustment pot meter. Yes, this is the soldering side of the Ham International Concorde 2, and here we have the legs of RV13 here, 1, 2, 3, and the input of RV13 here, this is this leg, is about 9.4 volts, 9.4 volts here, huh? Okay. And now we must make a small modification. We will cut this track here between the input leg of RV13 and the BAS point. Okay, on this point here, directly at the collector of Q36, we have source 13.4 volts here. And now we make a track here between this point and the leg of RV36 with a small white wire. Let's go. Okay, we start a modification. This is the leg here on RV13, the input leg on this side here, and here we have source 13.5 volts about. Okay. Yes, it's about 13.4 volts on the input of RV13. Okay, I'm back here. Now we will look the power after modification here. The low power is about 6.6 watts here, 6.6, and the high power about 11.5.6. Okay, now we will check the AM low power here, the PEP power, that key, about 5 watts, and now audio, about 15 watts, audio. And now we check the high power. Okay, that key, about 11 watts, and now audio, okay, audio, about 100% here, audio, and low power again. What's the modulation? Audio, also about 102% here. Okay, it's a very good modification. Yes, and here we have a special case. This is a YP2000 by Wilfried Peters. And this transceiver is already modified by the manufacturer, and this line here, this track here, is also a source track here, 13.8 volts directly after the on-off switch, and this track goes to the input of the RV13. Okay, and now on the final here on this video, we could make here the similar or the same modification here on the Ham International Multimode 3, Concar 3 or Jumbo 3. This is a PTBM131 or 133 schematic diagram, and it's always the same here. You must cut here the BAS, the 9 volt point here, cut. And now you make a new track here from source, from here to here again, and you have also 12 watts on high power and about 6 watts on low power. Okay, thank you very much. See you at the next video. Bye bye.